Here we're asked to find the magnitude and the direction of the resultant vector when we're combining the green and the blue vectors. So before I start going through these steps to find the exact answer, I just want to get a rough idea of where that resultant vector might be. So if I use that parallelogram rule, I can just try to create a parallel equivalent vector to this green one on the other side. Let's make that about right there. And the blue one, let's make a parallel equivalent vector, the blue one, right here. So that shows us that approximately our resultant vector is going to end right here, start at our origin. It's going to be right about there in our second quadrant. So now let's go through the steps to find the exact magnitude and direction of this purple vector. So the first step is to find the component form of this blue and green vector. So we are going to substitute in the magnitude and the direction for the blue vector first into these formulas. And when we put this in our calculator, we get approximately -8 and approximately 3. So I'll write that vector components as -8, 3. Now let's do the same for the green vector. And when we put these in our calculator, we get approximately 5 and approximately 1. So the components of vector W are 5, 1. Now we're going to add these x and y components to find the resultant vector. And so when we add the -8 and the 5 and add the 3 and the 1, we see that the resultant vector is at -3, 4, which if we look at that purple vector we initially drew, that makes sense to go to the left to -3 and to go up to +4. Now let's use these components to come up with the magnitude and the direction by substituting these into these two formulas here in step 3. So we need to remember that the -3 is our A and the 4 is our B. And when we do this, we see that the magnitude is 5. So that means the length of this purple vector is 5. And now to find the angle, let's substitute it into that second formula. And this is telling us that the angle is -53.1. So let's think about that. If we're here at 0, angle 0, -53.1 is down here in the fourth quadrant. It's not in the second quadrant. And so what step 4 says is that we need to add multiples of 180 degrees to move it to the correct quadrant. So to move it from the fourth quadrant all the way over here to the second quadrant, we're going to add one multiple of 180 degrees. And so 180 plus -53.1 gives us 126.9 degrees. So from 0, we don't care about that 53 anymore. From 0 over here to that purple vector is 126.9 degrees. That is our direction, and our magnitude is 5.